All right, so let's talk about scatter plots and the least squares regression line. We've got a few different questions that we're going to have a look at this evening. Again, to do this work, we need our calculators. So I hope everybody's got their calculator with them. We're going to talk about finding the equation of the least squares regression line, how we would use that to make a prediction, the correlation coefficient, et cetera, the sorts of questions that we would expect to see in our trials exam and again in our final exam. All right, so let's just have a look at the first question. It tells us the results as percentages obtained by a group of 12 students in the 2016 trial examination, and the corresponding final NSC examination is shown in the table below. Okay, so we can safely assume that the top row is always going to be our X row, and the bottom row we can always use as our Y row. If they give us data like this and they ask us, like they have done in the case of question 1.3.1, to calculate the equation of the least squares regression line, we would need to do that using our calculators. So get your calculators ready and let's just run through how we would enter the data. So the first thing that you would do, Matrix, is you would press the mode button. Choose option number 3, or if you've got a black or a blue calculator, like I do, I've only got the white one on here, then you would choose option number 2 for statistics. So option 3 on here, option 2 on black or blue or pink Casios. Then we're going to choose option 2. So A plus BX is the equation of the least squares regression line. So I'm going to press 2, and now I need to put in my X values and my Y values. So I'm going to put in the top row in the first column, pressing equals after each entry. Please do this as well on your calculators so that you can see that you're getting the same answers as I'm doing on screen. Okay, and once you've put in your X's, you can use your arrow buttons and go up to row number 1. And now we're going to put in our NSC exam marks. Okay, so 12 marks in each column. Once we get to this point, we're now ready to activate the statistics function of the calculator. Everybody ready? Okay, so once you've entered all the information, you're now going to press AC, Shift, 1, and we're going to choose option number 5 for regression, REG. So I'm going to press 5 and I'm going to press equals. Okay, so it's a good idea at this point to write down the value of A and B and R of the correlation coefficient, because you don't want to have to go and re-enter the data all over again to go and work out what R is. So invariably, they will ask you for the correlation coefficient, although they may not, but they probably will. So just make sure that you've got all this information written down. Okay, so 1.3.1, the value of A, if I want to know what my A value is, I'm going to press option 1. Let's just pop that over there, option number 1, and I'm going to press equals. Okay, so that gives me an A value of 28,15. Okay, my B value, I'm going to go AC, Shift, 1, 5, 2 equals, that gives me 0.66. And then just here on the side, I'm going to note what my correlation coefficient is. I'm going to go back, AC, Shift, whoopsie, AC, Shift, 1, 5, 3, equals 0,80. So rounding to 2 decimals is enough. Okay, so 2 decimal places is fine. All right, so what we would do now is the equation of the least squares regression line would be y equals a plus bx. So that's 28,56 plus 0,66x. Okay, so sometimes this is out of 2, sometimes it's out of 3. In this case, it's out of 2. So I'm going to give a mark on my a value and then on the second term as well. Okay, now they want us. Is everybody happy with that? Any questions before we move on? Okay, so the second, clear, good. Okay. Now, the second point where they want you to draw the equation of the least squares regression line on the grid, the best thing for you to do is to use, yes. Sorry, is there a question?
I muted them, sorry, because I don't
all right.
think
No,
it was a
that's fine. I
question.
didn't know if it was a question. I thought somebody said ma'am, but maybe not. Okay. So if they want us to draw the equation of the least squares regression line on the grid provided, the best way for us to do it is as follows. Okay. So that is to use the least squares regression line to actually calculate values. All right. So what's important is that our data cannot, our least squares regression line cannot go past the smallest number in our data set, and it cannot go past the biggest number in our data set. So in other words, it cannot go past this value over here, and it cannot go past that value over there, right? So if we draw a line of best fit, we could connect these two together like this, but I could connect them like that. Somebody else could connect them like this. Somebody else could connect them like that. And all of these are a little bit different. So if we all do the same thing, then our results are going to be that much more reliable. Okay, so if we have a look in our top row over here, we see that our smallest number is 41. Okay, so what we're going to do is we're going to go just inside of that and we're going to choose a number like 42, right? So I'm going to sub in to my least squares regression line and I'm going to work out what y is equal to when x is equal to 42. And I'm expecting an answer very similar to the 58 that I've got here. It's not going to be wildly different. Let's work out what that is. So 28.15. Oopsie, remember to go back to your computing mode on your calculator. I forgot to do that. What are you guys getting as an answer? When you sub in the 42, what are you guys getting as a y value? That's it. Me too. I'm also getting 55,87. All right. Now let's find the biggest number. Here it is. And let's choose something that's just a little bit smaller than our biggest. Okay, see how I'm going to explain myself again. I'm just writing this down. So something that is just a little bit smaller than 94, let's use 93. Okay, so see how we are not allowed to go past our smallest value or past our biggest value. Okay, so I can't draw my least squares regression line past here. Okay, and I can't draw it past there. So it's got to be somewhere in between these two pink lines. So if I choose a value that's just slightly bigger than my smallest one, I'm going to get as close to the smallest to this pink line as I possibly can on the left-hand side. If I choose a number that's just a little bit smaller than 94, I'm going to get as close to the pink line on the right-hand side. Okay, so we are drawing the equation of the least squares regression line. Okay, well, at least we are preparing to draw the equation of the least squares regression line. Okay, so now when we sub in the 93, what do we get? (89.53). Good. Okay, so now what this is giving us are 2 points, because we need 2 points in order to be able to draw a straight line. So the first point we're going to draw at 42 and 55.87. Our second point we're going to draw at 93 and 89. Let's just correct that. 89.53. So now I'm going to plot those 2 points. Yes, Tsegofatso. So 42 would be somewhere round about here. 55.87 is going to be somewhere round about there. Okay, so that is this point here that I've drawn. 93 and 89.59. So 93 will be, I don't know, I guess about here. And 89.59 would be somewhere round about there. Okay, so we cannot go past our smallest x or past our biggest x. And now we would get a ruler. You guys would get a ruler, and you would connect these two using a straight line. Okay, and that is the best way to draw the equation of the least squares regression line on your grid. Okay, so you're going to use a number that's just bigger than your minimum and another number that's just bigger than your maximum. You're going to sub those into your least squares regression line, get the corresponding y values, plot the points, and then connect the dots. Everybody happy?
Hello, ma'am.
Hello, Tsegofatso.
Ma'am, can I ask, ma'am? At school, ma'am, they taught us to write the line, the equation line from like the intercept to the mean point and the mean point and the y mean. So the way you did it, ma'am, I don't understand it that well, ma'am.
Okay, Tsegofatso. That's fine, but Tsegofatso, the problem is, okay, and I'm not saying what your teacher at school has done is incorrect, but you are not supposed to be drawing this to the y-intercept, because the data is only reliable between its smallest x and its biggest x. So we're not supposed to be extending the line beyond those points. So my line should go through the mean point anyway.
Oh, okay.
Okay. All right.
Yeah.
So it's not correct to draw from the y-intercept up to the smallest x, because the truth is we don't know. We can't say that this data that we've got here is going to be applicable to people that got less than 41%.
Yes.
Okay.
I see.
Because then we would be extrapolating instead of interpolating, and extrapolating is not necessarily going to give us reliable results. Okay.
Okay, ma'am.
All right. Kamagelo? No problem, Tsegofatso. Kamagelo?
Hi, ma'am.
Hi, how are you?
I'm all right, and yourself?
I'm fine, thank you. What's your question?
So, ma'am, I actually have a couple of questions.
Sure.
The first one is, when calculating the least squares regression line, can I use the, like, you see on the calculator, you can have, when you press like, let's see, there's that X with the line on top. Press shift like on.
Okay, so if I put it on, okay, and then I press shift, yes.
1. And then 4.
Oh, okay, no. So okay, so now there, that X with the line on top, that's the mean. Oh, I see what you're doing. You're doing what Tsegofatso was doing, and you're working with the mean point, aren't you?
Yes, so I'm gonna use the X and the Y. And
okay.
then
But then what are you going to connect that to?
And then I'm gonna say, you see the equation that we calculated.
Yes.
In place of X, I'm gonna put 0. So I'm gonna have my Y vector.
Okay. All right. Hang on a second. I know that some teachers, okay, so some teachers teach that, and I know our own textbook is guilty of exactly the same thing. Okay, but that is actually not the correct way to sketch the least squares regression line. Okay,
Right.
And the reason for that is because my smallest piece of data is 41. So in other words, if somebody got less than 41% for their trials exam, I don't know anything about marks that are less than 41. So if I extend my line beyond 41, so smaller than 41, I am saying that the data that I know nothing about is behaving in exactly the same way. I cannot make that assumption. I cannot assume that the data is just going to continue that direction. So that's actually not the best way to sketch the equation of the least squares regression line. This way over here, what I'm showing you here is going to be the most reliable because I'm not making any assumptions about the data outside of what it is that I'm looking at. Okay, so you are not supposed to extend the least squares regression line down to the y-axis. In fact, there were questions in the NSC paper. I must find that question for you guys, where extending the line to the, I'll find it for you and I'll do it with you on Thursday. Extending that line to the y-axis would make absolutely no sense at all. So if they asked you to draw the least squares regression line, it actually, you could not do it that way. All right, so that's why I'm showing you to do this. Because it is the best way. Okay, so Tsegofatso and Kamogelo, what you're supposed to do, let's just go through it one more time. I'm more than happy to do that, is look in the set of data for your smallest and your biggest values. So you can see here that 41 is your smallest X. Okay, so take something that's just slightly bigger than your smallest. Okay, so that's why I've chosen 42. Okay, if you worked with 43, it would be fine. If you worked with 44, it would be fine. Okay, because there's quite a big difference in the X's here, right? But something that's just bigger than your smallest. Sub it in and get your corresponding Y. That gives you this XY coordinate, right? Which is what this point is over here. This one in pink, okay? Then look for your biggest value. Your biggest value is 94. So choose something that's just smaller than 94. That's why I've picked 93. I've subbed that into my least squares regression line. I get 89.53, and that's why I've written this point over here, which is what this one is there. Grab your ruler, connect your two dots together. Okay, and that is the correct way in which to draw it.
So, ma'am, it only starts from that point, the smallest point. To
yes,
that,
point yes, absolutely. It's not going to go smaller than 41, and I'm not going to go past 94 either.
Okay, ma'am.
Okay,
then that's how we do it in the exam, ma'am, also.
And that's how you should do it in the exam as well, absolutely. Okay, and what I should find is that it probably will go through my mean point as well.
Okay, so ma'am, we add these new circles to the graph, the new circles we calculated, the new dots that we just calculated.
Yes, exactly. So the pink dot represents the 42 against the 55.87. And the purple dot represents the 93 against the 89.53. Okay. All right. No problem. So I've written down the correlation coefficient. So they've only asked for it in question 1.33. That's why it's good for me to make a note of it earlier. I'd get 1 mark for that. Then they've asked us to comment on the correlation between the trials exam and the final NSC exam. So 0.80 is what kind of correlation? So I need to comment on whether it's positive or negative, as well as its strength. So this would be positive. It is, well done, Seethley. It is a strong positive. Sorry, I should have said strong first and then positive correlation. Okay, so it's very important that I comment on both whether it's positive or negative and the strength of the correlation. Okay, if it's above 0.90, I must say very strong positive correlation. Okay, so if you just said strong correlation, you wouldn't get the mark. If you just said a positive correlation, you're not going to get the mark. Okay, so you must comment on whether it's positive or negative, as well as the strength to get that 1 mark. Okay, all right, and then the last question here, Matrix. A particular student scored 47 in trials. Use the equation of the least squares regression line to predict what this person will score in the final NSC exam. That's easy for us now. So we would just sub into y equals 28,15 plus 0.66 times, in this case, 47. Okay, so let's work out what his predicted mark would be. $59. Oh, it says 59,17 to 1 decimal place, so 59,2%. There we go. Okay, are there any questions before we move on? Everyone okay? Seketelo?
Ma'am.
Hello.
How do we identify if it's strong correlation or weak?
Oh, okay. All right. So, Seketelo, good question. The closer the correlation is to 0, the weaker it becomes. So there should be, in your textbooks, there's generally a table giving you the strength of the correlation. So if your correlation is anywhere from negative 0.3 to 0.3, we would say that it's weak. Okay, anywhere from negative 0.6 to like 0.6 would be, I don't know, I suppose it would also be considered probably moderate. Anywhere in between these would be considered weak to moderate. If you are now dealing with negative 0.8 to 0.8, it would be strong. And if you were dealing from 0.9 to, then it would be a very strong positive. So the idea is that the closer we get to 0, the weaker it becomes. Okay, and then you
thanks,
would,
ma'am.
okay, all right, no problem. Kamagelo? I don't know if that was your hand up from earlier. Did you have another question, Kamagelo?
Yes, I did, ma'am.
Okay.
On the correlation part, aren't we supposed to say like it's a positive, strong linear correlation, or like?
Yes. Yes. So that's why I've said here it's a positive, strong correlation. You're only going to do linear correlations. Okay, so you don't have to use the word linear, but you do need to comment on whether it's positive or negative and the strength of the correlation. Okay, so you have to say negative weak correlation or positive, very strong positive correlation. Okay.
All right, ma'am.
All right, kamachelo. All right, let's just hang on. There's just a couple of things in the chat. Sihle, it's like that, unfortunately. Oratile. Yes, so Oratile, the correlation coefficient basically describes how strongly the variable on the x-axis is related to the variable on the y-axis. That's the idea. Okay, so the closer the points lie on a straight line, the higher the correlation coefficient is going to be. The further the points are away from the line, the weaker or the smaller, the closer to zero the correlation coefficient is going to be. Okay, Oratile. Yes, how you can have a weak positive correlation. That would be possible. I don't really know what the point of something like that would be, but you're going to see in the next example. Okay, so it depends, Amahle, it depends on the value of B. If B is a positive number, then your line is going to slope up to the right. If B is negative, then your line is going to slope down to the right. So it's the gradient. Okay, B represents the gradient of the line. Okay, let's just have a look. There's a lot of questions coming through here. Yes, so Amatle, you're going to see in the next example, there's going to be a negative gradient. Okay. All right, Sihle, please ask your question.
Hi, ma'am.
Hi, Sihle.
Can you scroll down for me, please?
Sure. Is that enough?
Yes, ma'am. Hereby, oh, okay. Oh, okay, I got it. Sorry.
Are you sure?
Sorry. Yes, ma'am.
Okay. All right, no problem. All right, so let's have a look at the same sort of question on scatter plots and regression lines, but quite different, actually, quite different information from what we've got over here. Okay. So this question compares or describes the age of a person in years and the amount of money in rands that they spend on entertainment in a certain month. Again, the information is shown in the table and the scatter plot below. So they give us our X, our age. That's what would be on the X-axis. You can see age is down here. And on the Y-axis, the amount of money that they spend on entertainment. Now, look at the dots here and how far apart they are compared to the dots over here. Can you see here, the dots are more closely clustered around that green line, whereas here, they're much further apart. So here we would be expecting a correlation coefficient that's closer to zero than it would have been in this example over here. Okay, so they've asked us to write down the correlation coefficient. Can you guys work that out and tell me what you get as the correlation coefficient for this data? So you do that on your calculators and tell me what you get. Well done, Chrissy. Yes, Kamogelo, you try that on your own. I want to see what you get for the correlation coefficient. Oh, excuse me. That's it. That's it. Well done, everybody. Okay, so that is what you should be getting. So you can see in this situation here, we have got a correlation coefficient of negative 0.67. Look how much closer that number is to 0 compared to this one over here, which was 0.80. So here you can see those points, those black dots are much closer to the green line than what they would be to any kind of least squares regression line in this particular question. Okay, so here we would not say that a person's age and how much money that they spend on entertainment are closely correlated. Okay, so 0.67, even though it's negative, doesn't matter, it is not a strong correlation. Okay, it is a far more moderate correlation. Hello, Sihle.
Sorry again.
That's okay, don't say sorry.
Ma'am, I need help because I still got confused because
what are you confused about, Sihle? Sorry, please can the other person just mute? I can't hear Sihle.
where you
Thank you. Sorry, Sihle, off you go.
It's when you draw your graph, because our teacher told us that it doesn't always start at 0.
Correct.
So it confuses me sometimes.
Okay, so your teacher is right. Okay, your teacher should not be teaching you to draw the equation of the least squares regression line starting at the y-axis, because it does not always make sense for the line to touch the y-axis, nor can we say for any certainty that it applies to data outside of what we're working with. Okay, so in other words, if we look here, we don't know what happens if somebody was younger than 15. I mean, presumably people that are 10 years of age, you know, are probably not spending a lot of money on entertainment, but similarly, people that are 75 are probably not spending a lot of money on entertainment. So we can only use the equation of the least squares regression line to make predictions about people between the ages of 15 and 75. Anybody younger than 15 or older than 75, we cannot say that it's reliable, okay, because then we would be extrapolating, not interpolating. Okay, so what you are supposed to do, Sihle, is this. Look at your data and find a number that is slightly bigger than your minimum. So in this case, you've got 15 there. So let's use 16, because 16 is very close to 15. Okay, it's just inside. And now we're going to sub that into the equation of our least squares regression line. Okay, so in 1.2.3, they've given us the equation of the least squares regression line. Oh, sorry, in 1.2.4, that's when they want us to do it. Okay, so let's just answer 1.2.3 first, and then Sihle, we're going to do your question. All right, so to get or to predict how much a person at the age of 55 would spend on entertainment, we would sub 55 in here. So we would sub in our 55 over there. Okay, can you see this B value here, negative 9,6546, is negative. Okay, so that means that the gradient of our least squares regression line has to be negative. Yes, Kamogelo.
Ma'am, sorry, but could I please take you back a bit?
Sure.
I want to know if correlation is the same as relationship.
No, correlation is the strength of the relationship.
Oh.
Okay, so correlation is the strength of the relationship, and it also describes whether it is a negative correlation or whether it's a positive correlation.
Oh, all right, ma'am. That makes sense.
Okay, does that make sense? So it describes the strength of the relationship, because either you can have one, so as X gets bigger, Y gets bigger, or as X gets bigger, Y gets smaller. Okay, so either the relationship can be a positive one or it can be a negative one. Okay.
All right, ma'am. Thank you.
All right. You should be getting here, you should be getting 670,74. Okay, so we are saying that somebody of age of 55 would be spending 670 Rand and 74 cents approximately on entertainment in that month. Sikatelo?
Ma'am,
Hello.
I wanted to ask on 1.2.2, is it positive or negative moderate correlation?
Oh, so I was naughty. I left that off. I wrote moderate correlation, but I didn't write whether it was positive or negative. So I must say here that it's negative. Okay, so it's a moderate negative correlation. Okay, it's negative because of the negative in front of the 0.67. Thanks, Sikatelo, for pointing that out. Okay, we do need to say that. Okay. All right, so let's go back, Sitle, and answer your question, which is really what 1.2.4 was all about. Draw the least squares regression line on the grid. Okay, so Kamagelo, you had questions about this. Tegofatso, you were also asking about this. Let's practice this whole idea again. Okay, so go and look at the data. 15 is the smallest, so 16 is one bigger. So let's use 16. So I'm going to sub in here. And I'm going to work out what the y is when the x is 16. So 1201,74 minus 9,6546. And I'm going to sub in the 16. And we're going to end up with what? Are you guys getting 1047,27? Good. Well done, Sihawu. Well done, iPhone. That's it. And let's work out, let's have a look. So 75 is our biggest. Let's use something that's just smaller than 75. So again, we're going to sub in here, y equals 1201,74. Let's sub in the 74. I'm getting 487,30. Are you guys getting the same value? That's it. Well done, Sihawu. Velocian, same story as above. Okay, remember here, 41 was the smallest. We used one bigger, 42. 94 was the largest. We used one smaller, which was 93. We're doing exactly the same thing here. Okay, 15 is our smallest. We're using one bigger, which is 16. 75 is our biggest. That's why we're using one smaller, which was the 74. Okay, so we don't go past 15 and 75. Yes, you can. Kamogelo.
Hi, Lesego and everybody. So on 1.2.1, what we do is that on the calculator, we press shift, we press mode, and then we go to statistics mode.
Let me just call up my calculator and then I can follow you here. Hold on one second, Kamogelo, just hang on. Where's my calculator? Oh, it went away. There we go. Okay. All right, so Kamogelo, go for it. So say that again. On our,
So
we're going to go to?
Statistics mode.
Okay. Just give me 1 second here. So, sorry. Shift 9, 3. Equals AC. Okay, so into mode, into statistics. Okay, keep going.
And then we go into 2.
Mm-hmm.
And then we enter the data. So the H in years is for the X part.
Mm-hmm.
And the money spent on entertainment is for the Y part.
Lovely. So we're going to put in the 15, the 18, the 20, the 24, the 40, the 45, 70, and 75. And then we're going to, whoopsie, enter. And then we're going to scooch over and go up here, and we're going to put in 600, 950, 1250, 1050, 950, 300, 450. Okay, all yours again. Keep going,
After that,
mm-hmm.
we're going to press AC.
Mm-hmm.
And then we're going to go to Shift
Mm-hmm.
1.
Mm-hmm.
And then 5.
Good.
And then on the 5, we have number 3, which represents the letter R.
Mm-hmm.
And that's our correlation value.
Yes, good. Well done. So we would press 3 and equals, and there is the correlation coefficient. Okay, Lesego. Thank you, Kamogelo. That was beautifully explained.
Thank you, ma'am.
Thank you. Okay, Kamogelo, Lesego, that's where it comes from. Okay. All right, so that was 1.2.1. All right, back to question 1.2.4. Okay, so we chose 16 because it's just bigger than 15. And we subbed it into our equation of our least squares regression line, and we've got this value over here. So this is a point that we can draw on the graph. 16 is our x coordinate against 1047,27 is our y coordinate. So that point would be, let's have a look. So 16, these go up in 2, so that would be 2, 4. So this would be the line that's 16. 104, so let's just go up here, 104. So there would be 1,000 over here, 1,000. Sorry, it's 1047, comma 27. So there, that would be 1, 1, wouldn't it? So it's going to be smaller than that. So it's going to be somewhere round about here. Okay. And then we're going to do exactly the same thing with the 74. Okay, so here on this side of the upper end, our 74 is going to be plotted against the 487.30. That's going to also give us a point. So we've got 74 against 487.30. So our X and our Y. So 74 is going to be 72. This is 74 over there. Against 487. So 4, there's 4 there. That would be, it would be somewhere around about here. More or less. Okay, so we don't want to go past 75, and we don't want to go past 15 on the left. And now you're going to get a ruler matrix, and you're going to join these 2 points together. Okay. Like so. Okay, and that is the equation of the least squares regression line.
Hello, ma'am.
Hello, Tsegofatso.
Ma'am, can I ask, ma'am, in this type of question, ma'am, why don't they say draw the regression line of the interpolated data instead of
Good question. Good question, Tsegofatso. They should be more specific about that, but they don't. I think that they expect you to know that you must only draw the equation of the least squares regression line between the smallest and the biggest and not beyond that.
So, because ma'am, I'm confused. If I do write it this way in the prelims and the papers are marked by our teachers who taught us that other way, and would they mark me wrong? If they mark me wrong, can I fight and tell them this way is the recommended? Because I know in the finals, it's marked by a bunch of people who might know this way.
Absolutely, absolutely. So that's a difficult question. You see, the thing is, I don't want to say anything against anybody else. But yeah. You know what I think you should do? Why don't you go to school tomorrow and go and have a conversation with your teacher? You know, just ask your teacher if you can have 5 minutes after the bell has gone very quickly and just say, you know, is it okay for me to draw my least squares regression like this if it comes up in trials? Would you still mark it correct if I did it this way? Okay. And just see what your teacher says. The problem is that, and I know this for definite, if you've been taught something at school which is incorrect, and then you do that in finals, then you're going to end up losing those marks. So they might mark it right in trials, but then when it gets marked at finals, it's not going to be marked correct. And then you're going to be the one that is that's going to lose the marks. Exactly. I mean, nothing's going to happen to the teacher.
Yes. I get it. Thank you.
Okay. All right. But speak to your teacher and I'd be interested to hear actually, once you've had a conversation with your teacher, please share with us what your teacher says.
Okay, ma'am.
Okay. I'd like to know as well. All right. Okay. Something that should make you feel a lot better. I do not have as much experience as these teachers. I've only been teaching for 16 years, but there are people that I work with that have got more than 35 years worth of experience teaching maths for the Department of Education.
What you just said, my phone just paused for a while. I didn't hear what you said.
No, that's fine. I was just saying I've been teaching maths for 16 years. So I'm not as experienced as some of the people that I do work with. There's a woman that I work with that has been teaching maths. She's actually doing a slightly different job at our school now. She's taught maths for the Department of Education for more than 35 years. And she's a very good friend of mine. She's a lot older than me. And this is what I'm teaching you now. This is her method. This is the way she does it. And ever since she explained this to me years and years and years ago, I've always taught my matrics like this. So what I'm what I'm telling you now has been tried and tested for at least the last 35 years. So I think we're good. I think so. So. Okay, but just let's see what your teacher says. Okay. All right. Pleasure. Okay, so interpolation and extrapolation, these are not words that they can expect you to know, kamachelo, okay? But what we were doing here, where we subbed in the 55, we were interpolating. Over here, when we subbed in the 16 and the 74, again, we were interpolating. Okay, so interpolating or interpolation means using the equation of the least squares regression line to make predictions between my smallest x and my biggest x. If I want to extrapolate, then I would be using the equation of the least squares regression line to make a prediction about something that lies outside. So let's say I wanted to predict how much an 80-year-old would spend on entertainment. I could then go y equals 1201, 74. oh, not plus, it's minus 0, it's not 0, it's 9. Sorry, guys. 9,6546 times 80. Then I am extrapolating. So I'm using the data to say, okay, well, now I'm predicting what an 80-year-old would spend. This is not reliable. Okay, so my answer is irrelevant. Let's just work out what it is, but it's not really important what it is. Okay, so I'm predicting that an 80-year-old, according to my data, would spend around about 429 Rand and 37 cents on entertainment. That's extrapolating, okay, because I'm working outside of my maximum. Okay, Kamogelo. So this is not reliable at all. Sihle?
Sorry again.
No, please don't apologize.
I can't help it. I just need clarity on something real quick. Remember
Sure.
the previous question we did? There by 1.3.2.
Yes.
Can you?
You want me to go up here again?
Yes.
Yes.
There by that equation where we said y is equals to 28,15
Mm-hmm.
plus 0,66.
Mm-hmm.
So here we said plus on 1.3.2, yet on 1.2.3 we said minus. So can we get clarity on why the signs are changing?
Okay. So that's got to do. So the equation of the least squares regression line, Sihle, is in the form y equals mx plus c. So your y equals a plus bx is the same thing. What would be your m value? Here, your gradient is your b value. Okay, so if you have a look in this question up here, this plus 0.66, that is a positive number. So the line has a positive gradient. It slopes up to the right-hand side. Okay. In the case of this data over here, your gradient, your M value or B value is negative 9,6546, as you pointed out, okay, which is perfectly accurate. And look here, see there, your line has a negative gradient. Okay, so that's why there is a difference in this case. Okay.
Oh,
All
so
right. It's
when we calculated B, we got the negative 9 point. Oh, okay, okay, I got.
absolutely. Okay, so your B value on your calculator is the gradient of this line.
Oh,
Okay, maybe that makes things a little bit more understandable now. It explains a lot to
yes,
you.
ma'am. I
Good.
thought it was about the question, but no.
No.
Thank you, ma'am.
Pleasure, 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 pleasure. I'm so glad. I love it when we can fill in bits and pieces like that and you guys just understand these things so much better. Okay, so what we are finding, again, if we compare this information, all right, is that, and we would expect this, like what we're seeing here is I think, quite close to reality. All right. If you do well in your trials exams, or the better you do in your trials exams, the better we think you would do in your final NSC exams as well. I mean, it's unlikely for you to get, let's say you get 80% for your maths exam in trials. It's very unlikely that you're going to get 30% for finals, isn't it? We would expect a mark close to 80% for your final exam as well. Okay, so that's why there is this positive correlation. right? Or a positive gradient in this case, right? As you do better in trials, so we would expect you to do better in finals. Whereas here, it's completely different data, right? Here, they're comparing someone's age with the amount of money that they spend in entertainment. So again, we would expect people that are younger, like in their late teens. Okay, obviously you guys are still at school. You may not have a job yet because you're worried about passing matric. But you know, when you go to university, when you first start working, you're going to be spending more money on entertainment than say your parents are. Okay, or I would be, you know, once you get older and you have children, you know, you're going to be at home more. You're not going to be going to movies and going out for, you know, all sorts of things with your friends. Okay, so that's why here we would expect that as time goes on, people would be spending less and less on entertainment. That's why there is a negative gradient. Okay, Sihle, so it's very, very different data that's being described. And it's nice for you to see this because now you can see how different, it's the same question, but how different the information that's being given to you is. All right, even though they give us sort of more or less the same sorts of questions that they would expect us to answer.